All right, before watching this video on mechanical behavior, this is part 1 of chapter 6. You want to go ahead and watch the YouTube video that shows a tensile testing of a stainless steel sample and explains the use of an extensometer and how the stress strain curve is taken. And that's in Canvas for your convenience. All right, just a reminder that in the beginning of chapter 6, you will find the learning objectives, and we will take a look at all these learning objectives throughout this chapter. The exception being true stress and true strain. That is a little bit later in the chapter, so you don't have to worry about this learning objective. We are going to be sticking with engineering stress and engineering strain, which I'm going to go ahead and define. All right, so we could talk about a tension test, or we could talk about a compression test, just the reverse of the applied force. So in the tension test, we're pulling on the sample, we're stretching the sample and changing its length, increasing its length, and we would get some change in length delta L if we take a look at the length minus the original length. And if we were to go to take that delta L and divide it by this original length, then we would have the definition here of strain. Okay, so it's dimensionless, it's a length over a length. For compression, it would be exactly the same thing, except delta L would end up as a negative number, and we would have a negative strain value. The stress is defined as negative when it's in compression. That's a convention. And the stress is defined as that applied force divided by the initial cross-sectional area, and that would be in units of pascals. Shear stress and shear strain are defined as the distortion in the sample. So if we have a cubic block, say for example, and we were to apply a shear stress to the surface, this is kind of like having a deck of cards and pulling on the bottom of the deck and pushing on the top of the deck. You create a shear, and it distorts the shape of the original deck. And so we would define that distortion, that delta L for the change in length, as defined in this figure over the original length, as our shear strain. Okay? That's also the tangent of the angle of distortion. The shear stress is also defined as the force divided by that original area. It's just now that area is now parallel. So in the deck of cards example, the force is applied to the face of that top card and bottom card. That would be your original area.